Hello, everybody, and welcome to another episode of Connect Conversations. Today's conversation is all about Industry 4.0, digital twins, machine learning, artificial intelligence, and the future of these based on continuously emerging technologies. We have our special guest, Dr. David Howard of ERBESSD Instruments, with us today. And
how you doing?
Wave, David.
Yes, hello. Of course, we always have our host of Connect Conversations, Ron Moore, joining us as well. And I am Kim Fugger, the manager of Mobius Connect, and I will be the moderator for today's session. Well, before I officially pass the microphone over to you guys, I just want to encourage our audience here to submit any questions that you have right through the chat function. And Ron and David will be more than happy to answer your questions live on air today. We will air them anonymously, so no need to worry about getting called out. And I'm super excited. David and Ron are here to provide their advice and perspectives from their experiences, and they are here to help you. All right, guys, I'm going to officially pass it over to you.
All right. Thank you. And thank all the folks out there for joining us. Yeah, we've got a very special guest today in Dr. David Howard. I just want to make a few comments up front about this. We're going to be talking about so-called Industry 4.0. And as most of you know, I think, it started out with 1.0. I think that's steam, and then electricity, and then a little bit further industrialization. And now we're to this so-called 4.0. And to be clear here, David has the expertise. I'm a computer systems technical Neanderthal. So, you don't expect a whole lot of information from me, but I did want to make just some introductory comments. So what is this 4.0 thingy? And my very limited knowledge, and then I'll let David take over and handle the details and offer his views on all this. The first one is what you might think of as connectivity. Things like data storage and security, like blockchain and the iCloud or the cloud.
Sure.
I guess iCloud is a specific brand. Anyways, that's one of them. Maybe number two might be analytics and artificial intelligence. All that stuff we're kind of skeptical or scared even of today, but which can be an effective tool if properly used, and that's the big if we're dealing with. And then the third one might be the virtual reality and the automation of different things. Now, we've had automation for years and years, but this, I think, might take it to the next level in terms of applying all the technology. And then finally, maybe it's additive manufacturing. And so those are a few of and David, you correct any of that you think might be inappropriate. I got that off the web, so and it's not known for being, absolutely
Sure.
accurate. It's just lots of opinions floating around out there. So, just one more comment. One of the things I always worry about on this Industry 4.0, if I can't get people to put clean oil at a timely interval in their machines, I'm not sure how well this is going to play out in the actual practice out there. So, you can, throw a rock at that one too, if you want to. So, but over to you.
I don't think it's much of a rock, Ron. I think it's more of it's a reality, I mean, you have to commission it, install it, and maintain it. And before even all of that, the process or the asset needs to be engineered for its operating conditions and engineered for maintainability. And, those fundamentals of RCM don't necessarily go away at all. They still need to be in place, because you can put all the vibration analysis and connected technology you want. You could throw that all at a problem, but if you're not installing it, operating it, and maintaining it well, then you know what? It's just going to tell you have a problem.
Yeah, right.
So I agree with you there.
Okay.
I mean, one of the things that I think we're starting to see in this industry, and people have talked about it for a long time, is it's all about big data. And at what point is there such a thing as too much data? And one can argue one way or the other. And the frequency of data collection is typically based on things like criticality and things like that. But, in today's world, in this connected IoT world that we're living in, where we have home automation with, your Amazon Alexa and your Google Home and smart thermostats and video doorbells, it's only logical that consumer confidence is built in those technologies, those IoT consumer grade technologies first, which we've seen for the past, 10, 15 years, to now where we're starting to see it really take off in an industrial setting where the connected technologies are starting to be applied to our industrial assets in a manufacturing environment. So that's where the industry 4.0 is really starting to take off, or that buzzword, if you will. You're starting to see that big data collection and all of the analysis of that data as a result of the past 10 years of consumers becoming aware, familiar, and comfortable with that technology in their home or in their automobile or built into the wearable device that they're wearing.
Yeah. One concern I have about, just let's take one example, or maybe two, data analytics. The concern I have there is I see a lot of this stuff floating around out there for analyzing data, but I always look at that and wonder, is it really useful information? And so, and it befuddles me, because you can analyze something to death and still not have anything useful you can use. And then the second one is the security. As we all know, probably every one of us has been hacked at one point or another with some little thing. So I wonder if you might comment on this. And by the way, I've got a granddaughter who has a master's in data analytics. Sure. And I got a grandson who's his degrees will be in economics, but his focus is on that same topic. So I wonder if you could comment on how you minimize the risk of getting a lot of useless data and really condense it to information you can use to make decisions and make your plans and so on.
Well, so there's a lot of different variables and a lot of different ways that it can be approached. But if we think about it like this, for the past 30, 40 years, PLCs have been running our manufacturing operations, and those PLCs have been upgraded over time, and they've started using things like iHistorian and Pi to trend process variability and to trend process parameters like pump discharge pressure, tank levels and things like that. All of that sensor technology has been feeding our process automation systems for 20, 30, in some cases 40 years. So that data has not been traditionally readily available to the reliability engineer or the maintenance manager or the vibration analyst. Those folks have been almost siloed into their own predictive maintenance environment, and getting the operational context data has been a difficult challenge. But I think we can all agree that operational context data can provide very useful insight into why a machine might have a fault in terms of some kind of failure mode, whether it be a bearing fault frequency or a broken rotor bar or whatever it might be. There could be process variability and process variables that can contribute to analyzing that data. And that's where IoT in the predictive maintenance world, I think, is changing the most, because we're actually starting to incorporate that process automation data to give those reliability engineers, maintenance managers, analysts, and so on ready access to the information, rather than having to look at their reliability data on one screen and their process data on another. Those two things are intertwined so closely that giving them the information on both provides them the ability to make a more educated decision and a more action-based decision based on what they're actually seeing, rather than just reliability, vibration data, motor current data, infrared data, or whatever.
Yeah. One sort of, maybe it's related, back in my CSI days, we had a product called Master Trend.
Very familiar with it. I used it
Okay.
with my very first vibration analyzer, my very first portable, I should say.
Okay. So, but it was not really what I would think of as artificial intelligence, at least as the way I understand it today. It really gave you what a list of priorities to look at in terms of what the fault might be. And, you know, what was interesting to me, and I didn't really understand the underlying algorithms, was it'd say something like 80% probability that it's and unbalanced, and of 60% probability that's misalignment and so on. You add all those up, it's 232% or something. You go, what?
Right.
So
Yeah.
I'm assuming there was some overlap in there in terms of the probability. So you know, maybe comment on the difference between what a predictive algorithm that overlaps as opposed to genuine artificial intelligence.
Well, I think we can all agree that artificial intelligence is something, and machine learning is something that, you know, it's a sensitive topic right now, and it's something that, you know, I just read an article in Popular Science, or no, Popular Mechanics rather, about how the Air Force and DARPA had applied artificial intelligence and ML algorithms in a model for a drone to, you know, to teach the drone how to attack, what to attack, when to attack, but always with human intervention. And the drone was rewarded with points based on its actions. So if it took out a target that was approved by the operator that was maintaining the drones, or you know, operating the drone, so to speak, then that drone would receive points. So it learned that points were a positive behavior. So when one of the first rule in this article was that, you know, the drone in the model would do no harm to the operator. Well, the drone said, well, my first rule, the second rule is I need points. So what did the model do? It shot down the radio tower that was transmitting the signal from the operator to the drone so that it could get points. So now this is all a model. It didn't
Right.
really happen, but that's the reality of how serious and how carefully we need to think through these things. And when we talk about machine reliability and artificial intelligence, I'm a firm believer that, you know, machine learning we believe in federated or supervised machine learning. I don't know your plant. I don't know the facility in, you know, Taiwan that's, you know, installing technology. I don't know anything about their process or their assets, but I do know that we can identify anomalies. And those anomalies aren't based on learning as much as they're based on statistics. So linear regression, correlation, 95% confidence interval testing, those types of things identify anomalies, things that are statistically outliers,
Right.
so that we can then focus on, well, these outliers are presenting asynchronous energy as an example. Maybe we need to look at that data. I think that artificial intelligence and machine learning in terms of in our industry needs to be very carefully considered, because every person's operation, every person's plant, every asset, you can have two assets exactly the same sitting right next to each other, and they're not going to operate the same depending on how they were installed, commissioned, operated, maintained. There's so many variables that I think a statistical approach is responsible, and I think a supervised approach is responsible. But fully automated machine learning, I don't see it yet. Is it coming? Possibly, but is it available yet and actually reliable? I've not seen any data to support that.
Yeah. Well, it's like most of this stuff. It's a tool, and it's only as effective as you make it.
Yeah,
And so it's really important that, I think at least, that you have this human supervision to make sure you don't do something stupid
I agree
and
completely.
blow up a pump or a plant, you know.
Yeah,
So, and you've always gotten the so-called law of unintended consequences.
that's
No
right.
matter how well we design, plan, execute anything, you know, and then as you and I both know, in the military, you know, after the first shot's fired, the plans go to hell.
Yeah, stuff happens, right?
and you adapt as you
Yeah,
go based on your training and your knowledge and so on. So it just it just strikes me as what it would be foolhardy to just turn it loose and let it happen. And
right.
I just don't see that ever happening.
And that's why I think that the most responsible approach, whether it be applied in the reliability industry or anywhere, machine learning should be automated. It shouldn't be automated. It should be a supervised and federated process that always has human intervention and human eyes on it. It should optimize our human uh, our our ability. It should give us more time in our day. It should help us be more efficient, but it shouldn't be the end all be all in
Yeah,
anything, whether it be reliability or defense.
yeah. Uh, we we touched briefly on data storage in the cloud and so on. One of the things that I think most of us are coming across, and this relates back to I think all the so-called data uh, that we have. The more storage capacity we have, or the more crap. Well, maybe it's not crap, but more stuff. You know, a lot of mine might be considered just the other thing.
Sure.
That we tend to put on. You have any guidance on, keeping things what cleaner? I guess is the right word, because I've got stuff on my computer that's 20 years old,
Sure.
and I'm starting to run out of storage space, and I've got whatever it is, lots of storage space, at least from my, earlier technical days, such as they were. Any guidance on that?
Well, I think, from a reliability data perspective, one of the things that blows my mind is how emotional we are about our data, right? We are, all of us humans, it doesn't matter. I
Yeah,
have things on my computer that are 30 years old, photos from the military, or my discharge record or whatever. I have all of these things. We're sensitive to those things, but like, in the same token, in the reliability industry, you look at, people have vibration data that's 20 years old. Well, how good is that data? How many times has that asset been gone through a turnaround, been changed bearings? It probably isn't the same asset anymore. And that's where, there's systems in place and there's tools in place in a lot of the platforms that are available to help thin that data, to help recognize when there's an event that's different, and integration of our reliability and process systems with our CMMS systems, so
yeah,
that when that work order is closed, the CMMS system sends a message via OPC-UA or similar to the reliability system that says, hey, this asset's had a change in condition. Open the work order. There's the work order. The guy knows then that maybe that previous data can be culled at that point. And those
yeah.
things can be automated too.
Well, some of it boils right back to the discipline that you exercise. Much the same as it does for lubricating your machines at a properly. And to me, that seems to be not particularly well done in most of the operations I've been in. Well, you and I would both be accustomed to the concept of discipline and doing what you're told and doing what you say you're going to do and all that sort of thing.
That's
But
right.
it does seem to be less well exercised in the civilian world than it is, our previous worlds.
I would
Yeah.
say that you're absolutely right. I mean, if you look at like the top 10% of companies that, there's been lots of studies over the years, but, you know, the top 10% or the top 3% or whatever it is, I remember seeing one study where they said, this company they had an 18-to-1 ROI by implementing RCM and being disciplined and making sure that they, really followed the process and used the data that was collected to improve their process. 18-to-1 ROI, great. But is that sustainable? We oftentimes look at reliability as a short-term project rather than a long-term lifestyle, and the discipline that's required to maintain that long-term lifestyle. So
Yeah.
tools in the IoT space are meant to help us reinforce that reliability mindset more continuously rather than, oh, it's that time once a month I need to go collect my data. Now a
Yeah.
reliability engineer can focus on, hey, you know what? I have my data because of IoT. Let me make some action-based and very informed decisions based on the data.
Yeah. Okay. Let's touch a little bit on, and I may bounce back and forth here, a little bit about virtual reality. I've seen some tools that give you this three-dimensional picture of or a machine or a component, and you can, take it apart or put it back together virtually, as they say. Do you have any thoughts about the accuracy, the usefulness, and the the potential, not flaws, but things that could send you down the wrong path?
Well, I think virtual reality used in the right way presents a pretty unique opportunity because, if you talk to people like Joel Leonard or Joel Leonard, or some of the other guys that are Ian McKinnon, the craft skills guys. My dad's a retired millwright. I was a millwright for a short time after the military. The craft skills gap is growing. And that crisis of losing talent is starting to really it's starting to affect manufacturing operations around the world because the millwright that used to do the alignments has retired, and now the new millwright doesn't understand that he doesn't even understand what double dial indicators are, let alone how to use them, and then expects the machine to just do the job for him when you're talking about alignment as an example. So where I've seen virtual reality actually present some really interesting positive benefits is more in an augmented reality perspective where, the user, the mechanic in the field who's having a problem with a machine has these, goggles or glasses on with a camera so that the tech support expert, the subject matter expert on that piece of equipment is looking at it while the mechanic is looking at it, and they're working together to solve a problem. Almost like they call it augmented reality or, like a video conferencing, really. I mean, that's what it is. Now, when you talk about full virtual reality, one of the biggest challenges is like you see all these 3D models where you can take apart components and see how the innards of the machine work and understand it and really digest it, which is useful and helpful. But that doesn't take into consideration all the other things around that machine. Like, did they put in a proper hoisting mechanism to pull the motor, or is there something right above the motor that prevents them from lifting it up because when they built the plant, they didn't think about that. Those types of things have all bit us in the butt over the years, and that's where I think we need to be careful is, virtual reality, or virtual reality models, just like an ODS model or any other model, is only as good as the data you put into it. So if you put the time and effort to put in to make it as accurate as possible, the better the model, the better the result.
Yeah. Well, one caution I would offer our listeners or viewers, or whatever you might want to call it, is this is personal experience. YouTube has all kinds of tips and tools and videos on how to do things. And I had to replace I think it was a 4-way valve in my refrigerator. So the water dispenser, ice maker, and so on and so forth would work properly. And I watched the video and I thought, I can do that. And the guy did it in, I don't know, 5 or 10 minutes, just right. Well, I forgot about the fact I've got to empty the refrigerator and for one, and refill it. And another one, I forgot. Well, I don't know if I forgot, but I did what he instructed. And he got it done in 5 minutes, and took me forever to get one of the joints loose, and then took me forever to get it reattached. And I mean, took me, I don't know, an hour or two to do what looked like it ought to take 10 minutes. And I knew I couldn't do it like he did in, that short a time, but I figured, I ought to be able to get that done in half an hour, so much for that. So
I had a similar thing with my dishwasher about a month ago. I went to the exploded view on appliancedirect.com, found the parts I needed, watched a video, and I was like, oh, I can do this. I get the parts. They don't look like anything that's in the dishwasher now, and they don't look like anything in the video. So I sat there scratching my head for about 15 minutes and was like, oh, I get it. But it still took me 30 minutes while it took the other guy 5.
Yeah.
So
Well, and that's just a caution. You can have all the, virtual reality you want, but the guy doing the work still has to do the work. And if they haven't done it before, it's going to take them a lot longer to do it.
that's right.
So I'll just offer that. And it's a nice tool. I eventually got the job done, and, fingers crossed, so far it's holding, haven't spotted any leaks. So anyways, that's just a comment, about all this. I wanted to ask you, go ahead.
The only thing I was going to add to that, Ron, is like from a virtual reality, it's not necessarily, or augmented reality. When we talk about those things, we can also consider the whole digital twin concept, right? So, you have your asset, and that asset is, a fixed physical pump and motor, as an example, or a gas turbine or whatever. We've been doing digital twin modeling for a long time. I mean, look at FEA, look at ODS, look at, all of these other tools that we've been doing where we're applying different forcing functions and things like that to the model of the asset to see how it will affect the asset. Well, now with these connected technologies, with the whole IoT technology space that's continuing to evolve and continuing to develop, those data sets can be applied to those asset models, those digital twins, to see, okay, well, as an example, if you have 50 vibration wireless sensors that are on a steel mill or a paper mill, right? A paper machine, each one of those rolls is spinning at a different speed based on diameter. There's a main drive, but getting synchronous data across 50 sensors on a paper machine, as an example, so that all of those sensors record at the exact same time, you can then apply that data to the digital twin model to see, okay, well, what's really happening? And maybe that's causing a resonant effect on our suction press roll. And now we can visualize that and do some phase analysis between 2 points. The power of this connected technology is most certainly going to make our jobs easier as reliability professionals, but it's most important that we understand how to best use the data rather than just going out and buying a bunch of sensors and being like, okay, cool, I'm IoT, industry 4.0 now, I'm going to be more reliable. No, it doesn't exactly work that way. You still have to know what you're looking at and use the data appropriately to make data-driven decisions.
Yeah, well, and again, it's, how do we convert data into information that we can use effectively to do whatever it is we need to do to make the right decisions. And to me, there seems to be a gap in some of that. And, I'm just a dumb old hillbilly. I
don't know if I'd go that far, Ron. I know that many years ago, when I started my reliability professional career after the military, one of the first books that I read was something that somebody slammed on my desk and said, you need to read this, and it was your book. So I wouldn't call you a dumb hillbilly by any stretch.
Well, I try to make things simple enough even I can understand them, and usually that's more aligned with common sense.
Well, I certainly appreciate it because it helped me.
Yeah. Let's touch on so-called additive manufacturing. And, there's another phrase for additive manufacturing, and what the heck is it? That escapes me right now. But anyways, where you layer by layer, you create, things,
Sure.
in three-dimensional form.
Yep.
One of the things that I either heard or observed, and I don't remember now, was the fact that, you can make these things in that manner, but they almost always, or at the time, they almost always required some form of finishing, right? To validate and or finish the surface or make sure you have the right what tolerances and dimensional correctnesses and so on and so forth. Has that, have we reached a point where, that's no longer necessary, or is that going to always be necessary? What's your view on the, the current state and the future state of additive manufacturing?
Well, I think that, there's a couple of different ways to look at it. So I'll rewind, I don't know, 20 years or so when I was at a gas turbine repair facility in Houston, Texas, working for GE. And, at the time we were retipping the blades of turbine wheels. So, we would retip the blades after so many hours. They would send all the blades in from the turbine and compressor wheels. And, our team at the time, was a bunch of welders sitting at welding stations, manually welding those turbine blades, and layer by layer improving them to extend the life of the turbine blade itself. Well, back then, we also incorporated robots to weld, and those robots started welding. But then after the robot welded, it had to go get finished, NDI inspected, tolerances checked, all of these other things had to be checked. And to be honest with you, the precision of those technologies, robotic welding machines, has greatly improved. I mean, we use them to build our balancing machines. And I can say without question that, we still do our, NDE inspections on all the critical welds, but the failure rate compared to the human welder is, it's reduced so greatly that those checks take such a minimal amount of time compared to when you would have to do a fluorescent penetrant inspection on a blade that had been welded by a human. So I think the technology is improving, and I think that it's doing what it's supposed to be doing. It's giving us more time to do other activities that add value rather than reworking what an automation process did.
Yeah. Okay. Well, I guess the broader point here, of course, is that the technology will continue to be refined, but it's never might be too long a time frame, but for the foreseeable future, it will require some form of human intervention, validation, quality control, or whatever it may be, to get the finished product to the state where you want it to be.
Well, think of machining centers. I mean, machining centers back, 20 years ago versus a machining center today, a 5-axis Mazak can deliver such incredible precision and repeatability that as long as it's set up right, operated right, and maintained, like that, those machining centers are not the machining centers of yesteryear. And what that's resulting in is it's resulting in a higher quality product and less rework.
Yeah. Okay. Well, I wanted to ask you about, so-called blockchain. Okay. Now that apparently is a means by which you can have a highly secure access to information and data and so on and so forth. But I guess the question I have is, it would seem to me that would require a hell of a lot more computing power. And so my question might be, is it really worth it, or what applications might be best suited for the use of this so-called blockchain?
Well, blockchain relies on, it's like a distributed layer technology. So it allows you to distribute data across many different databases, but then with those different data sets in many different places, having a different visualization and analytical tools to pull that data in from all of those different sources. Do I see blockchain being applied in reliability? I'm not an expert on it, Ron, so I think I'd rather defer to another person that might attend one of these chats, because it's just it's not something that I've spent a lot of time on. I know the basics of it, but I know that it's primarily used in digital currency transactions right now in the crypto world. How that could be applied in our industry, there's probably somebody better that can speak to that.
Okay. Well, and that's fine. I may be speaking out of turn here, but cryptocurrency, I wouldn't touch with a 10-foot pole. It's a bunch of guys who create a bunch of numbers everybody goes looking for, and the only value it has is amongst the guys who created the numbers that are looking for the numbers.
I don't know.
Wow.
I'm still carrying cash in my wallet, so
Well, it just doesn't strike me that it's backed by, for example, like the U.S. economy. Our currency is backed by an economy and
mm,
backed by the Federal Reserve, and
right.
there are institutions behind our currency. And yeah, you can inflate or deflate over time depending on the circumstances. But it just strikes me that cryptocurrency is like, I don't know, it's like betting a lottery. I
Well,
don't.
it's like the Wild West. It's completely unregulated, and
Yeah.
as a result of that, that's why we're seeing, this Silicon Valley Bank failed as a result of many things, but one of them was the failure of one of the largest crypto exchanges in the world.
Yeah. Yeah.
So
So,
I'll
well,
I'll
and,
stick with cash for now.
yeah, well, and those out there who, are enamored with it, go ahead, do what you will.
Yep.
You just won't get me encouraging anything like that,
No,
so, uh,
myself either.
so let's see, what have I missed here? I've got connectivity, data source,
Let's talk about
security.
security.
Yeah. Okay.
Yeah, because I
All
think
right.
that's one of the biggest challenges. I mean, we're talking about connected devices, and in some cases, we're talking about thousands and hundreds of thousands of connected devices. If you think of a large manufacturer, you name, one of the top 10 manufacturers in the world, I don't care what industry, their asset base is huge. If they deploy IoT, that IoT technology then um, gets installed on all of these assets for monitoring and data and analytics and variance detection and things like that. Well, nobody's really talking about the security implications of that technology, and that's where I think that I'm personally very passionate about it because having come from the military, the security is like probably one of the most important things that we talk about. All troop movements, we didn't talk about troop movements, we didn't talk about where we were going on deployment, we didn't share information. And with all of this information out there, if it were to get into the wrong hands, let's say a competitor, could that give the competitor an unfair competitive advantage over the customer that's using it? So one of the things I tell people when they're really, really seriously looking into Industry 4.0, rolling out any kind of IoT technology in their plants, is to look at the security aspects of the system that they're considering. And I'm not saying that, one is better than the other. That's not this conversation. I'm just saying do your due diligence, because there are systems out there that are fully compliant with NIST and the Federal Information Processing System and many of these other very high level security systems. And then
Yeah.
there's systems out there that I've seen from other places in the world that there's so many holes in the system that anybody could get into it with a Bluetooth search app that I have on my phone. I can connect to sensors from other places very easily
Yeah.
using that. So I mean, there's that, and then there's besides the unfair competitive advantage, when you start connecting these sensors to things like your PLC, your Modbus, or your SCADA system, or any kind of controls architecture, that presents a whole nother risk. So we really, really need to be, as reliability professionals in our plants, doing our due diligence to make sure that whatever we're going to install is up to snuff from a security perspective. So I always tell people, make sure that you do that due diligence, understand what security is in place within the system you're considering before you jump into it wholeheartedly, because it's apples and oranges out there, and there's a lot of oranges and only a few apples that I've found in terms of meeting the standards from a security perspective.
Yeah. Well, and one secure way to do this, and I have the impression we do it, for example, with our voting system, is you don't hook it up to the internet, right?
Right.
You keep it isolated, so there's a lot less risk of, having data corrupted or
Hmm.
subterfuge and all that sort of thing. So, And
There's
so this,
isolation tools, but then there's also cryptographic tools. So isolation is like on
yeah,
a Navy nuclear submarine, it's all about isolation.
yeah,
Everything's on board, nothing transmits out unless it's through the secure SATCOM when they surface.
right.
That's the kind of thing that happens, in a military environment.
And that's all
Isolation.
encrypted.
Yeah, and that isolation is appropriate, and that isolation is appropriate in many other industries as well. Power generation. Our power grid is an aging grid with an aging infrastructure, and it's overloaded in many cases, and having that isolated from a connectivity perspective from the web or the internet is
Yeah,
is an appropriate technique. But in manufacturing, we have to balance the benefits, right? So pushing that data to the cloud, what does that give us when we put data on the cloud? Well, it's accessibility globally. It's it's superpower processing in terms of the ability for that to process the data to make an action or a data-driven decision quickly versus a local server. Most local servers don't have the power of these cloud servers. So you have to balance it. And that's where I think, again, talking about, what cryptographic techniques are available in the IO technology you're considering. Is the company that you're considering, do they understand IT to begin with? Are they ISO 27001 certified? That's a
yeah,
big deal. ISO 9001 has been known for generations as the quality management system standard. We all know it. It's been drilled in our heads as reliability and maintenance professionals what ISO 9001 is, or what the 55,000 series is. All of these are all things that we've become familiar with, but the 2700 or the 20 ISO 2700 or 27,000 is not something that we as reliability and maintenance professionals often think about because, well, that's IT's problem. Well, we need to think about that as responsible caretakers of our assets and our plants.
yeah.
So that's
Well, just a comment, if it doesn't need to be on the so-called web or internet, don't put it there.
sure.
So if you need to isolate it, keep it isolated and only transmit what you need to transmit. And I know that's kind of, what do you call it? High level pablum. But I think it applies in just about all circumstances. The
I
more you're connected, the greater risk you run of somebody sneaking in and creating chaos for you.
That's right.
Yeah,
Yeah, I mean, look at what happened with Colonial Pipeline down, on the east coast of the U.S. a couple years ago. We didn't have fuel because they got hacked,
yeah,
and fuel prices were going through the roof, and they weren't pumping fuel, and it was a mess. I think in critical infrastructure applications, isolation is absolutely important. I think there's a balance though, and I think the web
yeah.
or the cloud does offer value, but we need to understand the risks associated with it and weigh the pros and cons before we decide
Yeah.
we're going to put anything on the cloud.
Yeah, one concern I have, and this this shows up in spades in the Ukraine Russia war, and that is the ability to disrupt these systems through jamming and disrupting the signals that are coming and going that we have come to depend on totally, really.
Yeah.
And any thoughts on the what hardening our system so that they're less likely to be disrupted?
Well, I think, the disruption techniques that are available out there, let's rewind again. Let's talk about my days, the EF 111 in the Air Force, right?
Yeah,
We flew those things over Baghdad and jammed every signal known to man so that we could go in there and clean up the mess that Saddam created.
mhm,
Well, okay, that technology is starting to present itself commercially, and
right.
and that's a scary thing because you know what? My cell phone is my lifeline in so many ways. I
Yeah,
don't even have a home phone anymore. The office phones run off the internet, I mean, it is a scary thing. And I think that the type of hardening that is needed, it is starting to be implemented. You know, you see different channel hopping techniques when it talks about radio frequencies, to where like the device perhaps has the capability of transmitting across, let's say, 256 channels of radio frequencies, right? And this one time it transmits at this frequency, the next time it transmits at another, so that those jamming techniques are less likely to catch on to what the frequency pattern is.
Yeah.
So there are hardening techniques available, but at the end of the day, if somebody wants to jam it, I suppose, you know, there when there's a will, there's a way, Ron.
Well, or we may have a giant solar flare and we're all screwed. It
Or a
doesn't
big
matter.
EMP pulse, an EMP
Yeah.
pulse or something.
Right. So
Yeah,
anyways,
it's scary.
yeah, it is. I sort of get jammed right in my own house. That, my the Wi-Fi works well in every room but one.
Mm,
And in that room, which is closest to my neighbor, I've essentially got little or no signal. It's
yeah,
just awful. And
but
I don't know what he's
there's
doing to interrupt me, and I don't even know for sure that he's interrupting me, but something's happening. And I've turned off all the stuff I know to turn off to see if it might be,
that's probably that. In that case, it's probably just a signal propagation issue, and you can probably just install a booster or a mesh network that'll, it's probably just outside of the range of your router, or your router can't penetrate through a certain wall because it has steel studs. It could be
Yeah.
any number of things, but I doubt it's anything to do with your neighbor. I can promise you that.
Okay. All right. Well, I won't blame him. I haven't really blamed him. I've just put him on my list of suspects. Because he's into this, he does a lot of work from home, and he works
Sure.
for a big company, and so I'm suspicious of him. He's a nice guy. Don't get me
Yeah.
wrong. He's a super
Hopefully he's
good
not
guy.
listening to the podcast, right?
Right. Yeah. Well, he's in a different industry, so I hope not. But if he is, I'm sorry. You're a good neighbor.
Well, one of the things
And
that I think
well,
I
you've
wanted
just corrected me, so he doesn't have anything to worry about.
there you go. The other thing that I think that we should talk about is like edge processing and the power of processing. So
Okay.
what once took a huge, IBM Watson style mainframe to process information, right, is
Yeah.
now able to be processed on simple small devices like your cell phone or a Raspberry Pi or an Orange Pi. And these low power, high processing power, so they're low power consumption, but high processing or high computing power devices are
Yeah.
also changing things, because what they're doing is allowing us to process information closer to the asset. And that's what they call edge processing. And, like, let's just say an IoT gateway that has, a reasonably, a quad core processor, 16 gigs of RAM, and a bunch of other stuff in it. That can do a lot of the post processing right there at the asset to provide the information almost instantaneously, rather than pushing data to a cloud and then waiting for the cloud and dealing with latency and processing times. It might take a minute for the local device, but it might take 3 minutes for the cloud. So when instant
Yeah.
information is appropriate and useful, that's where these low power edge computing devices are starting to change the IoT industry as well, because those
Okay.
low power devices are actually creating an opportunity for more localized data processing
Okay.
and analytics.
Yeah. Well,
So,
and we see that every day as our quote so-called phone. I don't know if we should call it a phone anymore. You can make calls on it, but it's it does a whole lot more than just allow you to make calls.
oh, absolutely. Absolutely.
It's phenomenal in terms of what functioning capability it has. So
Well, if you look at the IoT industry as a whole, right now, the IoT analytics is forecasting, like, I don't know, 25 billion connections. It's some ridiculous number. It's a very large number,
yeah.
and the previous year's numbers also a very high number. It's not going away. Now it's time to, like, as reliability professionals, take a step back and go, well, if it's not going away, how can we leverage this to make our jobs easier, to make our plants run more efficiently, to produce a higher quality product, or whatever it is. And it's just another tool. It's no different than when, back in the day when you were at CSI, hey, Master Trend's a tool, the 2120 is a tool. Those things are great tools. Well, these are the tools that are being developed today based on all of the technology that's available today.
Yeah. Well, it looks like we're just about to come up to time to quit. Any closing comments or grand wisdom that you want to offer folks?
Well, I think Industry 4.0 has been here. It's arrived. It's been here for quite some time. I think now the next step in this proliferation, the next step in this process is, as reliability professionals, stepping back and looking at how we can use the technology to improve our facilities reliability, but also make us more efficient. So it's a tool. We should be looking at that tool as a means to an end. How can we be more efficient? How can we be more reliable without becoming overwhelmed, and making sure that we're secure? So I think that's one thing. And then the other thing that I think is important is, machine learning and artificial intelligence are still in their very, very early stages. They're exploratory. I mean, look at the example I used from Popular Mechanics, the article I just read. That was a model, and this was some of the smartest people the military has, and the model,
shut down the military.
Yeah. So I think what we need to do is we need to really, really seriously, as a human culture, but also as maintenance and reliability professionals, understand that it should be a supervised model. It should be a federated model, a reinforced model where human intervention is required, because fully automated is just plain irresponsible. And if anybody wants to argue that point, let's have another conversation.
Yeah. Okay. Well, I want to close with more mundane things. and all this high tech stuff. In my mind, at least, the key in any organization for the organization becoming effective, the keys, plural, are leadership, alignment, collaboration, and employee engagement.
Yeah.
If you can get all those things right, you're going to do well, and you're going to apply this technology really well. If you mess them up, it's not looking as bright for your future.
I agree.
So those are the kind of the 4 watchwords that I use when I'm out dealing with folks out there, no matter what the issue is.
Yeah.
So, all righty. But Kim, are you out there hanging back, waiting to be as soon as she gets her?
Oh. Sorry, I hit stop recording instead of unmute. I do apologize. But thank you guys both for another great conversation. Ron and David, you did such a great job. I do love always learning about the progresses that are coming, some of the change. David, you always do a great job bringing it back to what people do understand: cell phone uses, computer uses. When you're saying this is introductory, it feels like it is a bit farther away when it comes to like what our phones can do and AI. And so people need to take all of everything you guys said into consideration when they're looking into everything, and keep learning. That's the best thing, things
That's
evolve
right.
every single day. So just a quick reminder, you can see past episodes of Connect Conversations on YouTube, as well as Reliability Connect. Be on the lookout, as new episodes typically air every other Tuesday at 2 p.m. If you are interested in engaging with other industry professionals or would like to participate in the industry's live feed and forums on Mobius Connect, visit mobiusconnect.com. Please make sure to stay up to date with us on social media for the latest community happenings. And if you have any questions at all, you can email me directly at info@mobiusconnect.com. Thanks again for joining us. Have a great day. Please stay safe, and we will see you in 2 weeks.